What if I told you the most disruptive technology of the 21st century, the backbone of Bitcoin, and now a tool banks are betting billions on, didn't start in a Silicon Valley garage? It started with a classified ad. A small, unremarkable block of numbers, printed every single week in the New York Times, next to ads for used cars and apartment listings. Long before Satoshi Nakamoto. Long before the 2008 financial crisis. Two cryptographers were wrestling with one question. How do you prove a digital document hasn't been touched? Not one pixel, not one keystroke, since the moment it was created. Their answer would eventually be called blockchain. But in 1991, it was just a chain of hashes, hiding in plain sight in the newspaper of record. Most people think blockchain is just about magic internet money. It's not. It's a trust machine, a way for strangers, companies, even governments to agree on what's true without needing a middleman to referee. In this first part of our series, we're tearing down the mystery, where this technology actually came from, how it works under the hood, and why it's already quietly running through supply chains and banks you use every day. We're going back to the roots, 30 years of research that happened before Bitcoin ever existed. We'll open up a block and show you exactly what's inside it. Merkle trees, cryptographic hashes, and a structure that makes tampering almost mathematically impossible. And we'll show you the real dollar figures companies are already saving by using it. Figures in the hundreds of millions. By the end of this video, you won't just know what a blockchain is. You'll understand why some engineers call it the most important database ever built. The story doesn't start in 2008. It starts in 1991 at Bell Communications Research, in New Jersey. Cryptographers Stuart Haber and W. Stornetta were chasing a real, practical problem. How do you timestamp a digital file so it can never be secretly backdated, altered, or faked? In an age of easily edited digital photos and documents, courts and businesses needed proof. Their solution chained the fingerprints, the cryptographic hashes, of documents together with digital signatures. Structurally, that's a blockchain, built years before anyone used the word. To make it bulletproof, they didn't just store the record on a private server. In 1994, they founded a company called Surety and started publishing a hash, the fingerprint of that week's entire batch of time-stamped documents, as a paid classified ad in the New York Times, every Sunday. If anyone ever tried to secretly rewrite history, the fingerprint published in millions of physical newspapers wouldn't match. You'd have to alter every archived copy of the New York Times on Earth to get away with it. That ad is still running today. Decades later, it's considered the longest continuously operating blockchain in existence. And it's sitting quietly in the paper of record. In 1992, Haber and Stornetta upgraded the design, folding in a structure called a Merkle tree to bundle thousands of documents into a single timestamp instead of processing them one at a time. The work won a Discover Award for computer software innovation. And when Satoshi Nakamoto sat down to write the Bitcoin white paper in 2008, he cited Haber and Stornetta 3 separate times. The DNA of Bitcoin was already 17 years old. So if the pieces already existed, why did it take until 2008 for any of this to actually change the world? Nakamoto's real breakthrough wasn't inventing hashing or timestamping. That groundwork was already laid. The breakthrough was combining these existing pieces into the first system that could run without any central authority at all. No bank, no government, no company you'd have to trust. In the middle of the 2008 global financial crisis, as banks were collapsing and bailouts were dominating headlines, Nakamoto released a 9-page paper, Bitcoin, a peer-to-peer electronic cash system. Notably, the word blockchain never actually appears in it. Nakamoto simply called it a chain of blocks. On January 3, 2009, the very first block, the Genesis block, was mined. It launched a currency that solved something computer scientists had struggled with for decades, the double spend problem. How do you stop someone from spending the same digital dollar twice without a bank in the middle checking every transaction? Nakamoto's system solved it. And for the first time, digital money didn't need anyone's permission to exist. That's the history. Now let's open the hood and see how it actually works. Picture a batch of pending transactions, thousands of them, all waiting to be confirmed. Instead of stamping each one individually, they're organized into that Merkle tree we mentioned. Hashes of hashes, folded together, until you're left with one single root hash that mathematically represents every transaction underneath it. That's powerful for a simple reason. Any computer on the network can verify that one specific transaction belongs in the block without downloading and checking every other transaction inside it. It's a shortcut that doesn't sacrifice trust. That Merkle root gets combined with a timestamp and, this is the critical part, the hash of the block that came directly before it. That combination is stitched into something called the block header. And that link, block to block, is what actually makes it a chain. Here's why that matters. Because every block carries the fingerprint of the one before it. Changing even a single character in an old block changes its hash completely. And that breaks the fingerprint match for every single block that comes after it, all the way to the present. It's not that altering old records is illegal, it's that it's computationally self-evident the moment you try. So who's actually checking all of this? Not one company. Thousands of computers, all at once. A blockchain is a distributed ledger, meaning the record book isn't sitting on one company's server, it's copied across thousands of independent computers called nodes, scattered across the planet. But that raises an obvious question. How do thousands of strangers, who don't trust each other, agree on which version of the truth is correct? That agreement process is called a consensus mechanism. And there are two you'll hear about constantly. Proof of work is what Bitcoin uses. Miners burn real computing power and real electricity, racing to solve a complex math puzzle. First one to solve it gets to add the next block and earns a reward for their trouble. Think of it less like a race and more like a lottery where buying more computing power buys you more tickets. Proof of stake is the newer alternative. Instead of burning electricity, validators put up their own cryptocurrency as collateral, skin in the game, to earn the right to confirm transactions. In 2022, Ethereum made the switch from proof of work to proof of stake and cut its energy consumption by more than 99.95% overnight. That's the machinery. But here's the part that surprises most people. This isn't theoretical anymore. It's already running quietly through some of the biggest companies on Earth. Here's a number that should stop you. 2.2 seconds. In 2016, Walmart partnered with IBM to test whether blockchain could solve a genuinely dangerous problem: food contamination. Before blockchain, if a shipment of mangoes made someone sick, tracing that fruit back to the exact farm it came from took Walmart roughly 7 days of phone calls, paperwork, and guesswork. 7 days while a contaminated product potentially stayed on shelves. After moving that supply chain onto a blockchain ledger, where every farm, packer, and distributor logs data to the same shared, tamper-proof record, that same traceback took 2.2 seconds. Not 7 days, 2 seconds. That's not an incremental improvement, that's a different category of solving a problem. Banking tells a similar story. Financial institutions spend up to $500 million a year on something called Know Your Customer verification. The legally required process of confirming who a customer actually is over and over at every single bank they deal with. It's slow, it's repetitive, and it's expensive precisely because nobody trusts anyone else's paperwork. A shared blockchain record could let one verified check be securely reused across institutions instead of starting from zero every time. And in 2018, HSBC and ING used blockchain to issue a letter of credit for a shipment of soybeans traveling from Argentina to Malaysia. The kind of transaction that traditionally takes 5 to 10 days of paper shuffling between banks. It closed in under 24 hours. That's the reveal. This isn't a currency experiment anymore. It's unglamorous, unstoppable efficiency. And it's already inside the institutions you deal with every day, whether you've noticed or not. We've only scratched the surface of how this trust machine is reshaping the world. We've traced it back to a 1990s newspaper ad, opened up a block to see what's actually inside it, and shown you the real money already on the table. But this technology is running into hard physical limits. A blockchain doesn't grow for free. Can it keep scaling forever? And what happens when you combine an undeletable ledger with the raw power of artificial intelligence? That's exactly where we're headed in part 2. Thanks for sticking with us through the deep history on this one. It's a longer story than most people expect. If you learned something, a like genuinely helps this channel grow, and hit subscribe so part 2 lands in your feed. And if there's a technology, mystery, or piece of engineering you want us to dig into next, drop it in the comments. We read everyone, and a lot of our best episodes started right there.